So to just recap what I did before I remembered to press recording, or I didn't remember, was told, to find resonant frequency, or to find where the current is in phase with the source voltage, we're looking for where the imaginary part of the impedance is 0. So we have to find the total impedance and then figure out what frequency makes the imaginary part equal to 0. So we cast everything into the phasor domain and then just did some simplification. The right hand side had some things in series, so we put those together, and then that impedance is in parallel with the inductor, and all together it'll be in series with the capacitor right there. So then doing this, I'll have minus j over omega c1 plus product over sum j omega L times R minus J2 over omega C2. By the way, my Z's and 2's look identical, except that's why I always cross my Z's. And so when you see something that looks like that, it's definitely a 2, because if it was a Z, it would have a cross. I always put a cross in my Z's and never in my 2's. And then over the sum, which would be j omega L minus J2 over omega C2 plus R. And then I have no choice but to fill in some numbers, and I get minus J9231 over omega. So C1 is 108.33 times 10 to the negative 6. So 1 over that turns out to be 9,231. But the omega is in the denominator, plus did I really do all? Yeah, I really did. Okay, so plus when I multiply this out, I get, so j omega L times 2, so this part right here, so just this part is minus okay, so j times minus j is minus j squared, which is plus 1. So that becomes 2 omega L over omega C2, and the omegas cancel, plus j omega L R over j omega L minus J2 over omega C2 plus R. Okay, so then the 2L over C2 is 2,000. Plus J10 omega, when you plug in for L and R, over J times 0.2 omega minus J times what ends up being 10,000 over omega plus 50. Okay, so then you have to ask yourself, all right, that's all fine and dandy, that's good. What do I do from here? How in the world do I figure out what omega makes the imaginary part of this 0? And in order to do this, you have to get it into a plus jb form. And so I have to get this part right here. I have to get the j's out of the denominator. And so the way you do that is by multiplying by the conjugate. And so if you look, I'm just going to rewrite this. The same thing, I'm not going to do anything except rewrite it. 9231 over omega plus 2000 plus j10 omega over, and then if I write this as 50 plus j times 0.2 omega minus 10,000 over omega, then I can see what the real and imaginary parts are in the denominator. So then I can multiply by the conjugate, which is 50 minus j times 0.2 omega minus 10,000 over omega over 50 minus j times 0.2 omega minus 10,000 over omega. Which is minus j9231 over omega. And then plus 2000 plus j10 omega times 50 minus j times 0.2 omega minus 10,000 over omega all over 50 squared. Now the whole point of multiplying by the conjugate is that it makes it the real part squared plus the imaginary part squared without the imaginary number. All right, so now I'm real close to getting towards something that I can solve. So I need to get the imaginary part of this. So the imaginary part of this, well, the first part of this is imaginary, so and I need to set the imaginary part equal to 0. So minus j over 9231 over omega plus, and now the denominator is real, and so I just need to get the imaginary part of the numerator. This was 10,000. And so the imaginary part of the numerator, if you think about foiling this out, this part would be real, so I don't need that. And the j times j10 omega times that would be real, so I don't need that. And so the parts that I need are the 2000 times the minus j times 0.2 omega minus 10,000 over omega plus the j10 omega times 50, which is j500 omega. Okay, so that is the imaginary part. And so since I know it's the imaginary part, the real part, I don't need the real part anymore. I need the imaginary part to be 0. So I don't need the j's anymore. Everything has a j, so I don't need the j. I can take this to the other side, 9231 over omega, and on this side I have 2000 times 0.2 omega minus 10,000 over omega plus 500 omega over 50 squared plus 0.2 omega minus 10,000 over omega squared. Now, at this point, you can choose to believe me or not, but if you cross multiply and then combine like terms and do all of the algebra, what you end up with is 269.24 omega to the fourth minus 3.38 times 10 to the seventh omega squared plus 9.231 times 10 to the 11th equals 0. So if you can do that algebra on your own if you want to, or you can just believe me. I did in fact get the right answer, so this is correct. And this is in quadratic form, so this is like a x squared plus b x plus c equals 0. So using the quadratic formula, I get that omega squared, because when I use the quadratic formula I get omega squared, equals 401, that's either a 3 or a 5, 4, or omega squared equals 85384. Take the square root of both sides. Omega equals 200.3 radians per second, or omega equals 292.8 radians per second. So both of those are answers. You can't have a negative frequency, but those are both good positive frequencies. These are angular frequencies. If you wanted to get the resonant frequency, that's usually going to be F, and omega equals 2 pi F, and so F equals omega over 2 pi, and so that would be where's pi? 31.9 hertz, or 46.6 hertz. So that was not fun, but that was that. Okay, so questions on that? Do I think you would have to do this kind of algebra on a test? No, I don't think so. I don't know for a fact, but I don't think so. I do think you would need to know, you might have to do something that had simpler algebra. But I think I got this problem from, it was like one that he had on the website. Let's see. find the frequency that makes the impedance real. So if you look at this one, you can see that it's not as complicated as the one that I did, but it has so it has something in series with something in parallel. So it's still not very pleasant. And so is this? No, it's not the same one, but it's the same idea. So I thought it was important to go ahead and do one in case y'all haven't seen one. So any other questions?
Could you go back to your final answer?
Don't tell me that the very last thing I did, which was dividing by 2 pi, was wrong. Because I checked everything else.
I was plugging it into my calculator, the quadratic formula, to see if it would give me the same thing.
Oh, okay. Did it?
I don't know, not exactly, but is it different because it's to the fourth?
Well, that gives me omega
Because I see
squared,
yours.
not omega. So it should.
Okay.
So it gives me 40,134 and 85,000. So it gives me omega squared, and then I have to take the square root to get omega.
Okay.
Did you get these numbers?
No, but I could be plugging it in wrong.
Well, let me see. Let me see where I did the work. So I could have copied them wrong from here. These were the right answers from wherever I got this problem.
Oh, when I just plug it in, I just put what's in front of W4 and W2, huh?
Did you do times
Like I
10
don't
to
have
the
to do anything
7th
with
and
that?
times... Did you do times 10 to the 7th and times 10 to the 11th?
Yeah. Yeah, I
So,
did that. I don't know, it's just get, let's see, quad formula.
A 269.24. B negative 3.38 times 10 to the 7th. And C 9.231 times 10 to the 11th. 85,384 and 40,154. So, what calculator are you using?
I have the TI-84.
And you have a quadratic formula program?
Yeah, but it also, I don't know,
It,
maybe my program's just messed up.
it could be messing up with the size of these numbers.
X2. Why
It's
does it
a,
have X2 in the answer?
what's that?
Why does it say X2 equals instead of just X?
Oh, because it had two answers. So that's the
Oh, okay.
yeah, that's the first answer and that's the second
Yeah,
answer.
I don't know. It's giving it to me like this.
Uh, yeah, well, those are not right. So there could be a problem with your program.
Yeah, I'm gonna have to go look at that.
Yeah. If you want, I can send you a program that is pretty. Do you know how to load a program onto the calculator?
Yeah, I know how to edit and add it in.
Okay. All right. Yeah. It could just be that with the numbers this big that it makes mistakes. So it's
The
possible.
same calculator as him. I
Uh
was
huh.
wondering what program
Oh, it's
you're
not.
able.
It's not built in. It's not built in. You have to put a program in, and so if you come to my office, I'll be happy to show you how to do that. So it's not something that's built into the 84.
Oh, all right.
Yeah. It's yeah. You'd think it would be, but it's not. Um, so it's you can either enter a program by hand or you can get one off the internet and load it onto the calculator. And I can do that in office hours if you come by. Other questions?
Do you have office hours tomorrow?
Do I have office hours? So I will be in my office at 7 a.m. Yeah, so I'll be there from 7 to 8. Any takers? Let's see, what else have I got tomorrow? I will also be there. Ooh, tomorrow is rough. So um, I have to. Let me look at my calendar. I'm going to be on Zoom at about 3:15 to no, it'll be more like 3:30. Um, I have to go to my brother's house, and so I can't have a live session, but I will have a session 3:30 to about 4:45 or so. So that'll be Zoom. I'll send out a link for that, and that's going to be mostly just for answering questions. Um, and I'll be in my office at 7 a.m. And you might be able to catch me between 10 and 11. So, those.
I was just gonna come by for the code, but
Okay.
I mean, did you say you could just send it
Yeah, I can just send it as well.
or okay?
Yeah, I'll
Yeah,
do
yeah.
that. And I, I assume your name, I'll be able to get your email from. Uh,
Yeah, I mean, I can go and send you an email real quick.
yeah, why don't you send me an email and that'll remind me to get it to you.
All right.
Thank you, Rebecca.
You're welcome. So I am going to stop right now and go have some dinner, and I will see any of you who have questions tomorrow on at around 3:30 on Zoom, and I'll send out a link.
Thank you.
Okay.
Rebecca, I sent you a chat.
Oh, okay. All right, I'll check that. Lots of chats. You're welcome. Everybody's saying you're welcome. Yes. So you can tell your friend, yes, I will do that.
Okay, thank you.
Uh huh.
All right, I just sent it.
Okay. It'll be a
All
little
right,
bit
thank
later
you.
tonight that I'll send it.
Yeah, no rush. Text us
Okay.
until Friday.
Okay. All
All
right.
right.
Bye.
All right, have a good one.
You too.